Hello, hi, and we are from Group D, and our given title are Coagulations, and this is our group members, which is Nur Razia, and Noreen, Afika, Liwanjing, and Sarah Nadia, and Tenjahi, and Amira, and me itself. So let me explain about the introduction of the coagulation. What is coagulations? And consists the backbone process in the most water and advanced water treatment plants, and then it enhances a separation of species, and the primary usage is for the removal for the turbidity from the potable, and also it is an effective method to prepare the water from the removal of contamination, and lastly it will help to destabilization and accumulation of the difficult and slow to the settle the particular material. These are the what is coagulation? This is the introduction of the coagulation. So let's move to the process.
Hi everyone. Now I would like to talk about the coagulation process. Coagulation is a physical-chemical process that removes colloidal charged substances through charge modification or neutralization. It is a separation process whereby the repulsive forces on colloids are reduced through charge modification by incorporating specific chemicals known as coagulants. Hence, coagulation process can be referred as the destabilization of colloids that otherwise appear in a state of stable suspension. This process is commonly used to treat wastewater in chemical, pulp and paper, tile and textile, petrochemical, pharmaceutical, food, mineral processing, and metal industries. The primary objective of coagulation process is to change the surface properties of the particles by altering the charges. The particles will then agglomerate and form large particle sizes, which causes them to be separated from the solution. Next slide, please. So now I would like to talk about how coagulation works. There are three steps in coagulation. The first one is coagulant formation, then particle destabilization, and interparticle collision. The first two steps, coagulant formation and particle destabilization, occurs together. This happens as the coagulant is added in the water in a rapid mix basin for 20 to 30 seconds. This is done to ensure uniform distribution of chemicals and allow sufficient contact between the coagulant and the suspended particles. Then the interparticle collision occurs when gentle agitation is carried out for 15 to 30 minutes in a flocculation basin that consists of a turbine or pedal type mixers. This allows the agglomeration of the fine microflux into larger floc particles that will be eliminated in the downstream sedimentation or filtration process. Now I'll pass this presentation to Sarah, the next presenter.
Hello, there are two types of coagulant. First is organic coagulant, which include polyamines, melamine, formaldehyde, and tannin. For polyamines, they are usually widely used as organic coagulant, and it is very effective to treat wastewater and for high turbidity raw water. They also neutralize charged particle to avoid from forming bonding. Example of polyamines is polydimethyl ammonium chloride or polydetmag. Another one is melamine, formaldehyde, and tannin. They coagulate the colloidal material in the water. They also effectively treat the hazardous sludge, and they can absorb oil and grease. Next. The second type of coagulant is inorganic. Usually they use the aluminum or iron base. The inorganic coagulant are acidic and they demand meticulous care for handling and storing. They effectively treat low turbidity raw water. Compared to organic coagulant, inorganic coagulant is more cost effective. Example of inorganic coagulants are aluminum sulfate, aluminum chloride, and ferric sulfate. Next, I will pass to the next presenter.
Hello. Now I would like to talk about the factors affecting coagulation process. The first one is colloid concentration. The rate of coagulation depends on the contact between the available particles inside the colloid. So addition of a coagulant aid or recycling of settled sludge would improve the coagulation rate because there will be more reaction between the coagulant and the suspended particle. The second one is the zeta potential, which is the net charge of colloidal particles. If the higher the zeta potential, the greater the repulsive power between the particles. Hence, the more stable is the colloidal system. Therefore, lower zeta potential is preferable for agglomeration of the particles because the particles can collide with each other and form a larger flock. And the third one is temperature. At higher temperature, the velocity of molecules and kinetic energy increases. Therefore, the rate of chemical reaction between the coagulant and suspended particle also increases, and therefore the rate of coagulation also increases. Next is the affinity for water. Uh, hydrophilic colloids are stable because chemicals cannot readily replace the salt water molecules that is around the suspended particle. As for hydrophobic colloids, they can be easily coagulated and destabilized. Therefore, hydrophobic colloids are more preferable. And the next one is the pH. As Sarah mentioned just now, there are aluminum-based coagulants. So one of the example is aluminium hydroxide, AlOH3, which is amphoteric in nature and is soluble at low and high pH. Therefore, the greatest absorption occurs in the pH range of 5 to 7, where there is minimum solubility. And the last one is coagulant dosage. In the colloid system, the coagulant is increased progressively to the highest dosage. If there is too less of coagulants, there will be not enough coagulant to destabilize the colloid, and so when the coagulant is increased to the highest dosage, there will be an oversaturation with metal hydroxide precipitate that entraps the colloidal particles and produce very effective sweet coagulation. I would like to pass to the next person to talk about the advantages of coagulation.
Hello. So for the advantages of coagulation, firstly, it requires just short reaction time, which enable the pathogens to be killed within a few seconds. The total is around 1 to 3 minutes only for the coagulation process. Secondly, it requires no chemical. And third, it produces no taste or odor. Four, provide oxygen to the water after disinfecting. Next. Five, it destroy and remove the algae. Next, reacts with and remove all organic matter. And lastly, decay rapidly in water, which it helps to avoid any undesirable residual effect. So next for the disadvantage.
Hi. Okay, now we will talk about the disadvantages of the coagulation. The first one is high operating cost. Usually the sludge are high in volume, and the high volume of sludge will make it costly for the transportation. Other than that, the hazardous nature of the sludge will make it more expensive to be disposed of. Second one is the very complex process in choosing the most suitable colloidal system. In choosing the colloidal system, we first need to consider the variables such as the best type of coagulant, optimum dosage, and the best operating pH. Then we can determine the best colloidal system. And there are 4 types of colloidal system, which is the high colloidal concentration, low alkalinity for type 1. The type 2 is high colloidal concentration, high alkalinity. Type 3 is low colloidal concentration, high alkalinity. And type 4 is low colloidal concentration, low alkalinity. The third disadvantage is sludge volume. As the suspended As the suspended solids cluster together and fall, they will assemble at the bottom of the tank. It is estimated that the volume of the sludge can reach up to 0.5% of the volume of the treated water, meaning that if we have 1,000 gallons of raw water treated with the coagulation process, the resulting sludge can be up to 5 gallons. The first disadvantages is sludge are hazardous and disposal are costly. The sludge contains metal hydroxide and is often caustic with a pH of 10 or higher. Because of how hazardous the sludge is, companies will spend high amounts of money to treat sludge, transport, and disposal. The fifth disadvantage of coagulation is the complex dosage. In order to assure that the chemical coagulation water treatment process performs optimally, the correct dosages of the additive constituents must be considered. The rate and efficiency of the process can vary depending on the pH of the solution. Therefore, acid or bases must be added to ensure that the pH is at neutral level. After this step, the coagulant must be introduced in the optimal dosage, and this particular dosage is required to ensure that the effluent is fully destabilized. And the final disadvantages of coagulant is difficult to process multiple contaminants at once. Wastewater effluent often has many contaminants in it, and these contaminants can range from organic compounds to heavy metals to oils, fats, and hardness. There would be several chemical additives needed to treat different constituents. In some cases, another removal method would need to be used altogether. I'll pass to the next presenter.
Okay, as a conclusion from this presentation, coagulation is one of the conventional and simplest method for the treatment of water and wastewater, especially for non-suitable solids, turbidity and color from effluents. Coagulation also is an essential mechanism that occurs in most conventional water and wastewater treatment plants. And we can conclude that coagulation is the chemical water treatment process used to remove solids from water by manipulating electrostatic charges of particles suspended in water. By selecting the right coagulant for a system will enhance the overall system performance and particularly will improve the solid removal efficiency by enhancing filter and clarifier performance. Okay, thank you. That's all from us. Do you guys have any question?